We started working on self-driving cars 8 years ago, and the reason for that is because we reasoned early on that deep learning and artificial intelligence was going to reinvent the entire computing stack. And if we were ever going to understand how to navigate ourselves and how to guide the industry towards this new future, we have to get good at building the entire stack. Well, as I mentioned earlier, AI is a 5-layer cake. The lowest layer is land, power, and shell. In the case of robotics, the lowest layer is the car. The next layer above it is chips. GPUs, networking chips, CPUs, all that kind of stuff. The next layer above that is the infrastructure. That infrastructure, in this particular case, as I mentioned with physical AI, is Omniverse and Cosmos. And then above that are the models. And in the case of the models above that I've just shown you, the model here is called Alpamayo. And Alpamayo today is open sourced. This incredible body of work, it took several thousand people. Our AV team is several thousand people, just to put in perspective. Our partner, Ola, I think Ola is here in the audience somewhere, Mercedes, agreed to partner with us 5 years ago to go make all of this possible. We imagine that someday 1 billion cars on the road will all be autonomous. You could either have it be a robo-taxi that you're orchestrating and renting from somebody, or you could own it and it's driving by itself. Or you could decide to drive for yourself. And so, but every single car will have autonomous vehicle capability. Every single car will be AI powered. And so the model layer in this case is Alpamayo, and the application above that is the Mercedes-Benz. Okay, and so this entire stack is our first NVIDIA entire stack endeavor. And we've been working on it for this entire time, and I'm just so happy that the first AV car from NVIDIA is going to be on the road in Q1, and then it goes Europe in Q2, here in the United States in Q1, then Europe in Q2, and I think it's Asia in Q3 and Q4. And the powerful thing is that we're going to keep on updating it with next versions of Alpamayo and versions after that. There's no question in my mind now that this is going to be one of the largest robotics industries, and I'm so happy that we worked on it. And it taught us an enormous amount about how to help the rest of the world build robotic systems. That deep understanding and knowing how to build it ourselves, building the entire infrastructure ourselves, and knowing what kind of chips a robotic system would need. In this particular case, dual Orins, the next generation dual Thors. These processors are designed for robotic systems and was designed for the highest level of safety capability. This car just got rated. It just went to production. The Mercedes-Benz CLA was just rated by NCAP, the world's safest car. It is the only system that I know that has every single line of code, the chip, the system, every line of code, safety certified. The entire model system is based on sensors are diverse and redundant, and so is the self-driving car stack. The Alpamayo stack is trained end-to-end and has incredible skills. However, nobody knows until you drive it forever that it's going to be perfectly safe. And so the way we guardrail that is with another software stack, an entire AV stack underneath. That entire AV stack is built to be fully traceable. And it's taken us some 5 years to build that, some 6, 7 years actually, to build that second stack. These two software stacks are mirroring each other. And then we have a policy and safety evaluator decide, is this something that I'm very confident and can reason about driving very safely? If so, I'm going to have Alpamayo do it. If it's a circumstance that I'm not very confident in, and the safety policy evaluator decide that we're going to go back to a simpler, safer guardrail system, then it goes back to the classical AV stack. We're the only car in the world with both of these AV stacks running, and all safety systems should have diversity and redundancy. Well, our vision is that someday, every single car, every single truck will be autonomous. And we've been working towards that future. This entire stack is vertically integrated, of course, in the case of Mercedes-Benz. We built the entire stack together. We're going to deploy the car. We're going to operate the stack. We're going to maintain the stack for as long as we shall live. However, Like everything else we do as a company, we build the entire stack, but the entire stack is open for the ecosystem. And the ecosystem working with us to build L4 and robo-taxis is expanding, and it's going everywhere. I fully expect this to be, well, this is already a giant business for us. It's a giant business for us because they use it for training data, processing data, and training their models. They use it for synthetic data generation in some cases. In some companies, they pretty much just build the computers, the chips that are inside the car. And some companies work with us full stack. Some companies work with us some partial part of that. Okay, so it doesn't matter how much you decide to use. My only request is use a little bit of NVIDIA wherever you can. And, but the entire thing is open. Now, this is going to be the first large-scale, mainstream AI, physical AI market. And this is now, I think we can all agree, fully here. And this inflection point of going from not autonomous vehicles to autonomous vehicles is probably happening right about this time. In the next 10 years, I'm fairly certain a very, very large percentage of the world's cars will be autonomous or highly autonomous. But this basic technique that I just described in using the 3 computers, using synthetic data generation and simulation, applies to every form of robotic systems. It could be a robot that is just an articulator, a manipulator. Maybe it's a mobile robot. Maybe it's a fully humanoid robot. And so the next journey, the next era for robotic systems is going to be, robots. And these robots are going to come in all kinds of different sizes. And I invited some friends. Did they come? Hey guys, hurry up. I got a lot of stuff to cover. Come on, hurry. Did you tell R2-D2 you're going to be here? Did you? And C-3PO? Okay, all right, come here. Now one of the things that's really, you have Jetsons. They have little Jetson computers inside them. They're trained inside Omniverse. And how about this? Let's show everybody the simulator that you guys learned how to be robots in. You guys want to look at that? Okay, let's look at that. Run it, please. Isn't that amazing? That's how you learn to be a robot. You did it all inside Omniverse. And the robot simulator is called Isaac. Isaac Sim and Isaac Lab. And anybody who wants to build a robot, nobody's going to be as cute as you. But now we have look at all these friends that we have building robots. We're building big ones. Like I said, nobody's as cute as you guys are. But we have Neurobot and we have Agibot over there. We have LG over here. They just announced a new robot. Caterpillar, they've got the largest robots ever. That one delivers food to your house. That's connected to Uber Eats, and that's Surf Robot. I love those guys. Agility, Boston Dynamics, incredible. You got surgical robots. You got manipulated robots from Franca. You got Universal Robotics Robot, incredible number of different robots. And so this is the next chapter. We're going to talk a lot more about robotics in the future, but it's not just about the robots in the end. I know everything's about you guys. It's about getting there. And one of the most important industries in the world that will be revolutionized by physical AI and AI physics is the industry that started all of us. At NVIDIA, it wouldn't be possible if not for the companies that I'm about to talk to. And I'm so happy that all of them, starting with Cadence, is going to accelerate everything Cadence. CUDA-X integrated into all of their simulations and solvers. They've got NVIDIA physical AIs that they're going to use for different physical plants and plant simulations. You got AI physics being integrated into these systems. So whether it's an EDA or SDA, and in the future robotic systems, we're going to have basically the same technology that made you guys possible now completely revolutionize these design stacks. Synopsys. Without Synopsys, Synopsys and Cadence are completely indispensable in the world of chip design. Synopsys leads in logic design and IP. In the case of Cadence, they lead physical design, the place and route, and emulation and verification. Cadence is incredible at emulation and verification. Both of them are moving into the world of system design and system simulation. And so in the future, we're going to design your chips inside Cadence and inside Synopsys. We're going to design your systems and emulate the whole thing and simulate everything inside these tools. That's your future. We're going to you're going to be born inside these platforms. Pretty amazing, right? And so we're so happy that we're working with these industries. Just as we've integrated NVIDIA into Palantir and ServiceNow, we're integrating NVIDIA into the most computationally intensive simulation industries, Synopsys and Cadence. And today we're announcing that Siemens is also doing the same thing. We're going to integrate CUDA-X, physical AI, agentic AI, NeMo, Nemotron, deeply integrated into the world of Siemens. And the reason for that is this. First, we designed the chips, and all of it in the future will be accelerated by NVIDIA. You're going to be very happy about that. We're going to have agentic chip designers and system designers working with us, helping us do design, just as we have agentic software engineers helping our software engineers code today. And so we'll have agentic chip designers and system designers. We're going to create you inside this. But then we have to build you. We have to build the plants, the factories that manufacture you. We have to design the manufacturing lines that assemble all of you. And these manufacturing plants are going to be essentially gigantic robots. Incredible, isn't that right? I know. And so you're going to be designed in a computer. You're going to be made in a computer. You're going to be tested and evaluated in a computer long before you have to spend any time dealing with gravity. I know. Do you know how to deal with gravity? Can you jump? Can you jump? Okay, all right, don't show off. Okay, so now the industry that made NVIDIA possible, I'm just so happy that now the technology that we're creating is at a level of sophistication and capability that we can now help them revolutionize their industry. And so what started with them, we now have the opportunity to go back and help them revolutionize theirs. Let's take a look at the stuff that we're going to do with Siemens.